Today we will solve a question on full wave center type full wave rectifier. I have already written the question. In a center type full wave rectifier, RL, this is RL, load resistance, 1 kilo ohm. Each diode has a forward resistance of 10 ohm. Given the voltage across primary winding, this is primary winding. Let me show in this transformer, this is primary winding. 200 sine 3140 omega into T. We have already discussed, we represent AC in this manner also. This is Vm sine omega T. Find Imax, IDC, IRMS, VDC, VRMS, ripple factor, efficiency. This is RL. Here the primary voltage is given. One more thing is given. Turn ratio of the transformer. Turn ratio of the transformer. That is N2 by N1. Secondary half N2 by N1. N2 by N1. This turn upon this turn is 1 by 10. So first of all, we have to find the secondary voltage. Secondary, then all the calculation IDC, Imax, all we will perform. Imax, IDC, IRMS. So then we know that V2 by, for a transformer, V2 by V1 is equal to N2 by N1. So V2 is equal to turn ratio given 1 by 10 into V1, Vm sin omega T, which is Vm 200 sin omega 314 T. So V2 will be 20 sine 3 omega, this is omega, which is 2 pi f into T. We get, this is required for all our calculation, Vmax. So we have Vmax is equal to 20. Just let me rub this, because just note it down, because only Vm we will require. This is V2, we have got it. V2, so Vmax is 20. Let me write it here. This is of our importance, Vmax 20. Okay. How we got? Just write it in your copy. N2 by N1, V1 is V2. Okay. Vmax 20. Now Imax is maximum voltage upon resistance. RL, if you write RL, that means only RL, that means you are neglecting the diode resistance, forward resistance. You are assuming diode to be ideal. We can neglect, but I am including it. 20 by, since it is given, I am including it. RL is given 1 kilo ohm, 1 means 1000 plus 20. If you had neglected it, you had divided 20 by 1000. And I am including RF, so 20 by 1020. So there will be slight variation or slight difference in the calculation, in the result. Okay. But if it is given, better to include it. If it is given, better to include it. It comes out to be, I have already written 0.198. To reduce the calculation time, I have written the calculated result here. It is 119.8 milliampere. Okay. This is Imax. Now remaining all the values, IDC, IRMS depends upon Imax. Okay. So IDC, we have all for full wave rectifier, IDC is 2 Im by pi. For high wave rectifier it was Im by pi. Just in full wave rectifier it becomes double. Okay. 19.8 milliampere. Just I am writing milli 10 to the power minus 3 upon pi. It comes out to be 12.60 milliampere or 12.6 milliampere. Just note it down. And then IRMS. This comes out to be Im by root 2. We have already derived it. and that comes out to be Im is 19.8 milli upon √2. It comes out to be 14.0 or 14 milliampere. 14.0 milliampere or 14 milliampere. Now VDC, current into resistance. VDC means output DC. VDC represents the DC component of the output. IDC into RL. IDC 20.60, RN 1 kilo ohm. This was in milli, -3, and kilo. Both will -3 and +3. 10 to the power 0, 1. So it would be only 12.6 volt. No need to calculate. Just 12.61. 10 to the power 3 and 10 to the power -3 will adjust to 10 to the power 0. Now VRMS, voltage is equal to current into resistance. IRMS, which RMS? Output RMS. Output voltage RMS value. IRMS we have already calculated. 14 milliampere. Simply milli -3 into 1 +3 or -3. Let me write both of them. It will manage +3 -3 10 to the power -10 to the power 0 and 10 to the power 0 is equal to 1. 14 volt, just same result. 14, 14. Now ripple factor. Either you can calculate from the voltage or current. I am calculating from voltage. It comes out to be VRMS 14 upon 12.6 whole square minus 1, 0.48. Now efficiency. Total power, DC power output and total input power DC upon power. No difficulties in calculating DC power. You can either use VDC into IDC or VDC is IDC into RL. So you can use IDC square into RL. I am using this one. Both will give same result. IDC square 12.60 square into RL. RL is 1 kilo ohm plus 3 and -3 का square क्या हो? It will be -6. Square कर दिया, -3 का square it will be -6. So it will comes out to 12.60. I have already calculated. It comes out to be 12.6 का square. It comes 0.158. -3 square is 10 to the power -6 and this +3 from 1 kilo ohm. Okay, it comes out to 0.158 watt. No problem. If you calculated VDC into IDC, same result. VDC is 12.6, IDC is 12.6, same 12.6 square. Same result, 12.6. So both will give because VDC is IDC into RL. Same thing I have written. So no problem. P input, total power input, that is whenever you calculate total power, always multiply with RMS, use RMS value. So IRMS square RL. This power is only in this RL, but there is a power consumption. There is power consumption in diode also. In positive cycle, this diode, in negative cycle, this diode. Each cycle, one diode is on. So if you write only this, you are neglecting the power consumption across RF. But power input should include all the power input. So there is a power consumption in RF also. I have included it. Since RF is small, if you had neglected it, only 10 ohm, so there would be slight difference in the result. Better to include it. So I have included it. So IRMS square 14.00 square into RL plus RF is 1000 plus 20. 1000 plus 20. 1020. 10 or 20, it is 10, 1010. 20, okay. I have written 20 or 10. Let me check. I have given here 20 now. Okay, it is 10. It is 10. It is 10. So write here 10. 10, 10. It is when it was 10 was given. 10. Okay, 10,010. So it comes out to be 0.196. 0.196 watt. It was 10. I have, by mistake, I have written 20. It is 10. Okay. At a time, only one diode is on. If this is on, this is off. You can see Imax is RL plus RF. Okay. So it is 10. Just all the calculation I have done keeping 10 as RF. So it comes out to be, efficiency comes out to be PDC output upon total power input, including diode, power input in the diode, power consumption in the diode also. All I have included. If you had neglected, there will be slide, because diode resistance is quite small. Nah? If you neglected this, if somebody has neglected it, he will write 1000. Those who have included, it will write 1010. So slight difference will be there in the answer. Now efficiency is PDC upon total power input in percentage 100. It comes out to be 0.158 upon 0.196 into 100, 80%. So in this way we solved. You can use this formula also, VDC into IDC, और here VRMS आप ये भी यूज कर सकते हैं. लेकिन इसमें क्या कर दिया मैंने, VRMS यहाँ का वोल्टेज है, करंट इसी ब्रांच का है, तो मैंने क्या किया, इस VRMS कैलकुलेशन करने में तो मैंने क्या यहाँ का पावर लिखा, VRMS and IRMS, this voltage into this current, this power. So we neglected this. In this formula, while if you use this formula, you have neglected RF. So better use this one. Okay? You can use this one also. There will be slight difference in the answer. VRMS. Either VDC, power voltage into resistor current, or this. You can use any one, but I have used IDC square into RF. Okay? So this way we solve this question. You practice, and I am just writing a question for you. Turn ratio 20, 2 kilo ohm. Just solve homework and comment it. Comment it. This question. Comment this. Comment the answer. I will check it. Okay. This is your homework. RL, just change RL to 2 kilo ohm. And diode forward resistance 20 ohm. Then solve it. Similarly. Okay, thank you.